In this video, I will be defining pH and pOH of a solution and as well establish the formula for calculating pH and pOH. But first, take note that the concept of pH defines acidity for us, and the concept of pOH defines basicity or alkalinity for us. Is that okay? pH scale was suggested by Sorensen in 1909 with the aim to help us determine the concentration of hydrogen ion. By definition, pH is defined as the negative logarithm to base 10 of hydrogen ion concentration. Once again, negative logarithm to base 10 of hydrogen ion concentration defines our pH for us. Is that okay? And then, following that definition, we can actually write a mathematical equation for pH. Simply that pH is equal to minus log of hydrogen ion concentration to base what? 10. That's what we have in equation 4 here. This is our pH. We have equal to minus log of hydrogen ion concentration. Please take note that hydrogen ion concentration C. Okay, let's where do I put that down? Alright, hydrogen ion concentration, let me write that here. CH positive can still be given as this. Alright, you use a square bracket and then you put hydrogen ion in that square bracket. It's still the same thing, alright? So equation 4 defines the pH of a solution for us mathematically. How do we get the concentration of hydrogen ion from this equation 4? We might just choose to take antilog. Is that okay? Take antilog of the pH and get a value. That antilog is still the same as applying the definition of logarithm. In mathematics, in one of our previous class in math, I already defined logarithm as the power to which the base of that logarithm will be raised in order to get the number. So if I tell you log n to base b, what's going to be the answer? The answer is the power to which b will be raised to get n. On the base of that, to get the hydrogen ion concentration here, because this is just like minus log of this number, which is hydrogen ion concentration to base 10. So if I want to get this number, hydrogen ion concentration, all I need to do is to take this 10 to a given power. And that power is obtained from here because this logarithm now, first of all, I'll transfer this minus here. I'm going to have minus pH equal to log of concentration of hydrogen ion to base 10. We're just dealing with mathematics here now, in logarithm. So if negative is here, I will have log concentration of hydrogen ion to base 10. All I need to do is to raise this 10 to the power of minus pH. What it's going to give to me will be concentration of hydrogen ion. And that is why I wrote this equation 4a. That for us to get hydrogen ion concentration, it's simply 10 raised to the power of minus pH. Now let us look at pOH. Is that okay? The definition is similar to pH. pOH is simply defined as negative logarithm to base 10 of hydroxyl ion concentration. The hydroxyl ion concentration is still the same as saying hydroxide ion concentration. And of course, mathematically, we have equation 5 defining that for us, that pOH is equal to minus log of the concentration of the hydroxyl ion to base what? 10. Equation 5a is to help us get this hydroxide ion concentration. All we need to do is to still apply the definition of logarithm. Simply transfer this negative here. You have minus pOH equal to log of the hydroxyl ion concentration to base 10. Then to get this hydroxyl ion concentration, raise this base 10 to the power of what? Negative pOH. That gives us equation 5a. Now that we've defined and established the formula for pH and pOH, I'd like us to quickly revisit our ionic product of water. Remember, once again, I told you that that equation is fundamental. We already established that ionic product of water is simply Kw, which is equal to Concentration of hydrogen ion times concentration of what? Hydroxyl. That is hydroxide ion. That's the equation here. And I stated that at 25 degrees centigrade, the value of this product is equal to 10 raised to the power minus 14. So what do? Just want to solve a little mathematics here, okay? Simply come to this hydrogen ion concentration, CH positive. I already established the value for it, and the formula for hydrogen ion concentration, equation 4a star. Alright, equation 4a, I didn't star it. Is equal to 10 raised to the power minus pH. So in place of this concentration of hydrogen ion, I'll put 10 raised to the power minus pH, which is what I have here. Then I'm multiplying it by hydroxyl ion concentration, which equation 5a defines for us. 10 raised to the power minus pOH. So I fixed that for these. Make everything equal to what? 10 raised to the power minus 14. Because this is a ionic product of water at 25 degrees centigrade. In conclusion, you can apply indices law here, multiplication law of indices. This is base 10 to power minus pH, base 10 to power minus pOH. Mathematical sign between them is times. So pick one of the bases because they are the same and add their powers. If you do that here, what you're going to get to be 10 raised to power minus pH plus minus pOH. That's what you're going to get. And minus is common. Since minus is common to this power, bring out the minus. You're going to have 10 raised to power minus open bracket pH plus pOH. You can put that down and work it out. Just pure indices law of mathematics, multiplication law to be specific. So once I now get only one term here as 10 raised to power minus open bracket pH plus pOH, I'll simply make it equal to what? 10 raised to power minus 14. And of course, according to the initial equation, you know what's going to happen. The 10, base 10 here will cancel base 10 here, alright? And so you will now have pH, that's negative bracket, pH plus pOH close bracket equal to negative 14. The minus will cancel out from both sides of the equation and we get a pH plus pOH is equal to 14. A very important equation as well too. It is time we are now set to define pKa and pKw. Remember, Ka is ionization constant of an acid. We established that already. And Kw is a ionic product of water. So we're going to define their pK value, alright? And that we'll see in the next video, after which we solve questions based on all we've established so far.